In this lesson, we're going to be talking about surface area and volume of composite solids. When solving problems that involve composite solids, you need to utilize all the methods you have studied during this topic. When finding the surface area of a composite solid, you need to consider all aspects of the shape, including inside some shapes. Most find it easier, and that's most people, find it easier to determine the volume of a solid rather than its surface area. And now you're going to find out why. An example that we're going to be looking at involves this cube here, or we'll just say a rectangular prism. We don't know it's a cube for sure. And you can see that it's got a cylinder cut out of it. So we have to consider the fact that depending on which way you're looking at it, you may or may not know what's actually going on with the solid. So the first thing we need to do in regards to steps of finding the surface area of a composite solid is to visualize the surfaces of the solid. Then we need to write a formula and calculate the surface area of each face. And then we need to add the area of each surface together. We need to make sure that we actually check that all surfaces have been counted, because this is where people make lots of mistakes. And then when you're done, you need to write the answer with correct units and check that the number of decimal places from the question is correct. So the first example, we're going to be talking about that red cube, so it was a cube, which is actually a sculpture in New York. And it's consisting of a cube with a cylindrical hole removed from the center. The side length of the cube is 8.53 meters, and the radius of the cylindrical hole is 1.42 meters. Now there's several parts to this, but we'll just start off with A. What is the surface area of the face with the cylindrical hole? We need to go correct to 2 decimal places. So the first thing we need to consider as the formula is the area will be the square, and we need to take away the circle. So we know that the area of a square is BH, or side squared, and we know that the area of a circle is pi r squared. So my formula will be BH minus pi r squared. Now we know that the base and the height will be the same. It's going to be 8.53 for the side lengths of the cube. And for the radius, we get told it's 1.42 meters. So we're going to take away pi times 1.42 squared. And when we type that all into the calculator, we'll get 66.4261, which is approximately 66.43 meters squared to 2 decimal places. Now part B asks, what is the surface area of the red cube? Include only the outer red surfaces. And then we need to answer correct to 2 decimal places. So just remember that when we were looking at that picture, there were some parts that were black and some parts that were red. And we only care about the red parts. So for the surface area, we have 2 lots of the shape that we mentioned, which was 2 times 66.43 from our part A. Then we have 4 other sides of the cube, but they don't have cylinders in them. So we're just going to do 4 lots of 8.53 times 8.53, which is just the area of the square without that cylinder removed, or the circle removed. So once we type that all into our calculator, we get 423.895, which is approximately 423.90 meters squared. And that's correct to 2 decimal places. To find the volume of a composite solid, as I said, most people find this easier. We need to divide the composite solid into 2 or more common solids. Then calculate the volume of each solid, add or subtract the volumes, and then write the answer. So in this example here, there's no picture for this, it's just straight question. A grain silo consists of a cylinder with a cone on top. The diameter of the cylinder is 16 meters and the height is 20 meters. The diameter of the base of the cone is the same as that of the cylinder and its height is 2 meters. What is the volume of the silo? Correct to 1 decimal place. So we know that for the volume, it's going to be the volume of the cone plus the volume of the cylinder. So the volume of the cone will be 1/3 times pi times r squared times h, which we learnt in our last lesson how to work with cones. And then for the cylinder, it's pi times r squared h, which we also learnt in a previous lesson. All we need to do now is just substitute the values in from the question. So for the cone, it said that the diameter was the same as the cylinder, which was 16, but we need to halve it for the radius, which is 8, and the height of it was 2. So we can see that there. And for the cylinder, same radius, 8, but now the height is 20, so we need to substitute that in. When we type that into the calculator, we get 4,155.275 going on, which to one decimal place is 4,155.3 cubic meters. And that brings us to the end of finding volume of a composite solid. In our next lesson, we're going to be finishing off the topic with capacity.